Welcome to this lesson on maximizing the area. And this is when we're given a set perimeter, we're going to try to find the maximum area. So two things here, you're going to be given a set perimeter and we're going to maximize or find the largest area basically is what we're saying. Okay. The best way for me to teach this lesson is probably doing a few examples. Once you've seen a few, it sort of comes together fairly well. Okay, so the example I'm going to start with is an Elmer Fudd farmer example. This is a very common example because it sort of fits the um, type of question we're dealing with. So Elmer Fudd, one of our Looney Tune fans, wants to build a regular pen, a rectangular pen in a field on his farm. He purchases 120 meters of fencing, which included a gate. What dimensions should Elmer build his pen in order to maximize the area of the pen? So we want to make the pen as big as possible as far as an area is concerned. And there's different ways we can do it. Okay. So first of all, you should understand that the area of a rectangle is length times width. I think most of you know that. And we have 120 meters. Okay. So we have a total of 120 meters of fencing. And this is just a sample of potentially what it might look like, right? And so what we're going to do is pick different values for the width and length and work on finding a area for each of those and then decide which one's the best, okay? So the first one I'm gonna just sort of randomly choose. I'm gonna say, well, what if I wanted to do a width of 20 meters, okay? Well, if that's 20 meters, then this one is 20 meters as well. And so I need to find my length. If this is my width, I need to find my length. And so it's gonna be 120 meters minus 20 meters minus 20 meters. And that is gonna equal 80 meters. I have 80 meters of fence left, but it has to be split between both sides. And so this would be 40 meters and this would be 40 meters. Now, it's important that you double check your math and that 20 plus 40, 20 plus 40 all add up to 120 meters. If you're not 120 meters, then something's wrong. You're either probably too big or too small, and you're not going to necessarily find the correct area associated with a fencing. You didn't either use all of it or you tried to cheat and give them more. So now what we can do is we can put in our values here. We can say that this is 20 meters and this is 40 meters. And that gives me an area of 20 times 40, which is 800 meters squared. We can put our units in here if we like. And that's pretty good. Like you're going, oh, that's pretty good, Elmer. We're doing really good. What, though, would happen if we kind of altered or changed those dimensions? So we have to think about other options. For example, what if we decided to, instead of using 20 meters, maybe we changed it up? Like, what if we wanted to do 10 meters? Like, let's just do that. Like, say 10 meters here and 10 meters here. Well, that's going to change it all around. And so this is going to be 120 meters now. Subtract 10 meters, subtract 10 meters. That's going to give me 100 meters of fencing left, which I have to split between the two sides. So that's going to give me 50 meters here and 50 meters here. And of course, 10 plus 50 plus 10 plus 50 equals 120. That's crucial. And now I can find the area of my pen in this situation. Just going to erase some stuff here by taking my 10 meters as my width and multiplying it by my 50 meters as my length. And I get 500 meters squared. Wow. Well, that wasn't good. I mean, I don't want to recommend that to Elmer because poor Elmer is going to get a smaller area than he had before. So that did not work at all. So now what I do is I come along and I'm going to change this. I'm going to go, now that didn't work. How about we try 25 meters? If we make our width a little bigger, maybe that helps us. So we go to 25 meters and 25 meters. Well, that changes things here. That's 120 minus 25 minus 25, and that leaves me with 70 meters, which equals 35 meters here because I have to split the 70 meters in two to find out my dimensions for my pen. So now I'm at 25 times 35. Now this is a little harder to calculate in your head, so you might turn around, grab your calculator, and do this one math on your calculator. So my calculator is doing something funny with me here. Oh, there we go. Clear. And I've got 25 times 35, and that equals 875 meters squared. So in fact, I have done even better. Well, the next obvious question is, well, what if we jump it up even more? What if we make this 30 meters, for example? Well, if I go to 30 meters, what happens? I end up with 30 meters by 30 meters. And that is now going to be 120 subtract 30 twice. And that leaves me with 60. When I divide that in two, oh, this becomes 30 meters by 30 meters. It's no longer a rectangle then, it would actually be a square, but a square is typically a type of rectangle. So now when I say 30 meters times 30 meters, and what does that come out to? Wow, it comes out to 900 meters squared. And I'm suspicious, and I suspect you are too, that that's probably the best answer. I'm not going to do any better than that. But I have to be 100% sure, I should fill in a couple more. I should maybe check 31 meters, for example. What if I went to 31 meters? Well, that's going to actually go 120 minus 31 minus 31. That's going to give me 58. And so that's going to be 29 meters, right? And let's see what happens when I do 31 times 29. And it's important that you double check these. Sometimes you think you've got the biggest, and you turn out, well, I don't. So I go 31 times 29, and that works out to 899 meters squared. So it actually does get slightly smaller. Although you only lose 1 square meter in total, it is slightly smaller by doing it in that dimension. Now I could also, one could argue, well, what if we change this to 29? Well, if I change this to 29, that's just going to become 31. I'm going to be back in the same boat. So I'm basically prepared to tell Elmer that his best bet is to make a fence pen area of 30 meters by 30 meters, and that's a square. And so I should include a therefore statement. Therefore, Elmer should make his pen 30 meters by 30 meters for a 900 meter square pen. And that's what she would do. Now, what you're going to find, as long as you are given, you have no constraints and you're given a perimeter and there's no other constraints involved, building a square is almost always, well, is always going to be the most spacious or the maximizing the area of perimeter, okay? Now, there are situations, though, where things change, right? And so let's look at the next question that Elmer throws at us because, he's a pretty clever guy. And he says, Elmer then changes his mind, as farmers often do. He decides he would like to move the pen. He'd like to move the pen alongside his barn, meaning that he has need only use 3 sides, as the barn would form the 4 sides of the pen. So the fencing would only be used for 3 sides and the pen for the 4th. And so you can go on. I think I actually put an extra. He'd like to move the. I think we delete that there. Okay. You can cross it off on yours. And then we can come to this diagram, and this kind of gives you a better sense of what that image was. So if the barn is going to be here and the pen is going to be alongside the barn, he doesn't need to use fencing on this side. Okay, so this side no longer needs fencing. Okay, So most students look at this and go, okay, well, I suspect, let's do some suspicion here. Last time a square worked best. Well, what would the dimensions be if I have 120 meters and I want to make this like kind of square like? Well, then I would take my 120 and I would divide it by 3, and that would give me 40 meters. And I could say, I could simply say that each side, each side of the pen is going to be 40 meters. I'm going to go turn my pen back on, 40 meters here, 40 meters here, and 40 meters here. And clearly, in doing that, I have a lovely rectangular, or in this case, square pen that would be right up against the barn. I mean, that's got to be the maximum area because, I mean, a square worked on our last one, so squares got to work here. Okay, so what do is we actually want to test this out. We want to check and see if this actually worked. Okay, so what we do is we say, well, 40 meters times 40 meters. And what's that going to work out to? Ooh, it works out to 1,600 meters squared. That's quite a bit bigger than the last one, but remember we have a whole side of the barn that's acting as part of our fence. So we don't have to worry about wasting fencing there. So this is clearly a, wise way to go for Mr. Fudd, Farmer Fudd, right? Now, if we want, we should check to see if what would happen if we went a little further out or a little wider across. I mean, we should do some tests here to see. We shouldn't just assume that this is 100% correct, right? So the next test I'm going to do is I'm going to say, well, what if I switch this up a bit and go, well, I won't do 41, but let's say I do 45 along this side, okay? And see if this makes it better or worse for me, okay? So if I took 5 meters extra fencing here and here, I added an extra 5 meters on each side, this side's going to have to be only 30 meters. And you can simply do that math by taking your 120 meters, subtracting 45 twice, and that leaves me with 30 meters, and that 30 meters could go in here. And so now my width is going to be 45, or you could say your length, whatever way you want to do it. And then this one is 30, okay? Now I have 45 times 30, and let's check and see how the math does here. Do we get bigger in area or do we get smaller? So once again, with my trusty calculator, I clear everything. 45 times 30 equals 1,350. So that's obviously a smaller number, 1,350 meters squared. We've reduced our area. So that didn't work for us. But what if I turned around and I said, well, what if I made that side shorter? Go back to my 40. Instead of 40 on the width here, what if I said, well, I want to make that shorter. I'm going to go to 35. That means I have an extra 10 meters because I save 5 meters here and 5 meters here. My 40 here should go to 50. And if again, it's 120 minus 35 minus 35. And that leaves me with 50 meters along this side. And if you don't believe me, just add up 35 and 35 plus 50. That's still going to give me 120 meters. So this time I write in 35 times 50. And we do the math on that and see. And if it comes out less than 1,600, I probably have 1,600 is probably my best answer. And I think that's what most students usually think is going to be the result. And guess what? They're wrong. It comes out to 1,750 meters squared. Wow. So that actually was a bigger value, right? It actually shows that as I start to shorten this length and make it longer, make this whole thing longer this way, it actually gave me more area. Okay, well, let's try it again. Let's do one more. What if I shorten it up a little bit more from 35 to 30 and see what happens? Well, if I go to 30 here, by 30, guess what this works out to? Well, that's 120 minus 30 minus 30. That equals 60. and that leaves me with 60 here. So I can go 30 times 60. And what does that equal? Well, that equals, if you use your calculator, 1,800 meters squared. Uh-oh, that's even bigger. Now I might want to go a little further to see if it's going to continue to go one more step. So it's a little bit of a guessing game here. We actually call this method of discovering the answer trial and error. And believe it or not, trial and error is probably used by you more than anything. Most of the things you've learned in your life are actually by trial and error. So I'm going to take the 30 away. I'm going to get even smaller. I'm going to go to 25. I'm going to bust the bank, go down to 25, and I go 120 minus 25 minus 25. That's 50 off. That leaves me with 70 here. And I'm going to go 25 times 70. Well, what's 25 times 70? Well, you're going to see 25 times 70 equals 1750. Now, there we go. We finally see it come back down again. So it went up, 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 and then back down. And the cool thing is the difference here when we keep going by fives was the same. So we're pretty sure we've got the right answer. What we could do is we could try one at 29 and one at 30 just to make sure. So let's go to 29 times, and what will that be? Well, if I go to 29, this will be 62. Okay, I'm going to save over 30. I'm going to save a meter on each side. So that's 62. And let's see what I get for an answer. 29 times 62. And that's 1,798 meters. And of course, watch what happens when I go to 31. And this becomes a 58. Okay, so 31 becomes a 58, and it's 31 times 58, and it's exactly the same answer, 1798. And so meters squared. And so what we find is that our correct or best answer actually is back up here, okay? And we can now write a concluding statement. So therefore, Elmer should build his pen 30 meters by 60 meters by the barn for a total area of 1,800 meters squared. Okay, and we have our total area. So you can see now what maybe you thought it was going to be a square, much like the last time. That was not the case. Okay, and we can go down and we can do one more question. Of course, Mrs. Fudd comes along and says she would like the fence to be used to make 2 equal-sized pens in the middle of the field. Of course, Elmer has no choice. He must now agree. What dimensions of the 2 pens would maximize the area for the fencing? So this is where it gets kind of complicated, because now all of a sudden our pen looks like this. And a lot of kids will want to do this. They'll say, well, that's easy, real easy. We'll just go we'll say 30 by 30. I mean, that makes sense, just like a square. And this side's 30 and this side's 30. But the problem is we need fencing in here as well. And we've already used the whole 120 meters. So that's not going to work. We cannot do that. So let's get those 30s out of there, because that is not going to happen. Now, watch how we do this. Let's say I did want to do 30 by 30. Well, I want to use 30 here. What I have is 30, 30, and 30. So that means I have 120 minus 30 3 times, right? And that gives me only 30 meters left. So that means this side has to be 15 meters and this side has to be 15 meters. So in a roundabout way, what I'm going to do is say 15 times 30. And that would give me a specific area. Now, as you might expect, that's probably not going to be my best answer. I'm just going to reduce the size of my screen here so I can hopefully work and you can see all of my work while I go. Okay, that should give me enough work for now. And then I'm going to put my cursor in here so my screen's less likely to jump. And I got 15 times 30, which works out to be 450 meters squared. Okay, so the total pen would be 450 meters squared. Now, what if I changed my mind and I said, well, I think we can make that 30 a little smaller, right? Like that's probably pretty big. And so I'm just going to erase my 30s here and my 15s. I'm going to say, well, what if we made this only 25? And this is 25, and this is 25. So now I add those up. I've got 75 meters of fencing gone. So I can say 120 minus 25 minus 25, or I can just say minus 75, which would leave me with approximately 40, well, exactly 45 meters, I believe, right? 45 meters has to be divided by 2, so that means each side here would be 22.5 and 22.5, okay? And so now I can go to my calculator, fill in these, so the width would be 22.5 and the length would be 25, and once again, go to my calculator and do the math, 22.5 times 25, and that works out to 562.5 meters squared, okay? And now I can look at it and go, well, it's getting better. I actually improved. My area got quite a bit bigger, so maybe I'm on the right track. And so the next step I might go is, well, let's see if I jump another 5. I cut another 5 off here. What's going to happen? And so I make this 20 meters now. 20 by 20 by 20. And so that's 120 minus 320s is 60. That leaves me with 60 meters left, which I split between both sides. So this side's going to be 30 and this side's going to be 30. And what's my total area going to be? Well, let's do it. My width is 20 and my length is going to be 30 now. Okay. And 20 times 30, oh, that works out to 600 meters squared. Well, this is looking promising. I continue to just get bigger and bigger. I got to try the next one. You got to go to 15, right? And see if sooner or later we got to, have it hit a wall here. So I'm going to try 15. So go 15, 15, 15. So that's 120 minus 3 15s. Well, that's actually 45, right? 120 minus 45 equals 75, right? I believe that's correct, 75 meters. And I got to divide that in half. So that works out to 37.5, 37.5. So now I got 15 meters and 37.5. Well, what's my area going to be here? Well, 15 times 37.5. And what does it equal? Oh, son of a gun, that's a number I've seen before. 562.5 meters squared. Well, that's the same as the number up here, and they're smaller than my middle number. Now, to be safe, I might want to try a couple of them in between. For example, I might want to choose 21 here, and I might want to choose 19. In both cases, the length is going to be different, so we can't just assume these things. And if you work it out, your length here will be 28.5, and your area will come out to 598 meters squared. And down here, my length will work out to 31.5, and my area again comes out to 598 meters squared. And you can do the math on those to confirm it, but it works out. And in the end, what happens? Our best area is right here with a 20 by 30. Now, let's go back and take one quick look at this, okay? I'm going to erase these dimensions on here. We're going to put the proper ones on. So this is going to be 20, 20, 20, and our total here will be 30. That means each pen will be 15. Same thing over here, 30, each pen will be 15. And we can add this all up too. 20, 20, 20 is actually adds up to 60, 15 and 15 adds up to 30, and then another 30, and all of it together adds up to 120 meters. So we haven't gone over the 120 meter mark. So we can tell Mrs. Fudd, right? Therefore, we can say, therefore, Mrs. Fudd can make 2 pens 15 by 20 for a max area of, what was it, 600 meters squared. Okay, so a maximum area of 600 meters squared is what she can do. If she makes them 15 by, I should put my meters in here. I should sneak them in there. Okay, and that sums up basically the lesson on the perimeter, or maximizing area given perimeter. But there is one last little thing that's kind of fun to do, and that is, what if Elmer wanted to make a circular pen? Now, this isn't really part of the curriculum, so don't worry about it, right? But I'm going to show you what would happen if he decided, oh, screw it, I'm going to make a round pen. I don't like square things. I like round stuff. Well, what you have to understand is that you first use circumference equals pi times diameter, okay? Well, he has 120 meters of fence, so 120 equals pi times d. So the diameter equals 120 divided by your pi, which is 3.14. So if he was to use all of his pen and make a circle, he would get a diameter of 120, okay, divided by 3.14. And that equals a 38, I'm going to say 38.2 meters, okay? Let's round it off. Now, what's his radius going to be? Well, his radius is going to be half of that. So he's going to have to take his that number and divide it by 2, which I think is 19.1. Sorry, 19.1 meters. And the area then would become pi r squared. Okay? And pi r squared being the area is going to be pi times 19.1 squared. And so I can put this into my calculator and get an answer here. Okay, so it's going to be 19.1 squared equals, and then I'm going to multiply that by 3.14, and I get an answer of 1,145.5 meters squared. And I like to compare that to if we made it a square. And if you recall back, if you did make it a square, it would have been a 30 by 30, and that gave us an area of 900 meters squared. So if Elmer was not too concerned and didn't care, he could actually make it into a circle, and your circle would be actually the most advantageous. But I'm going to be honest, that's not part of this course. They almost always strictly teach it from the perspective of making a square. But I always like to point out to kids that actually, you know what? The circle's the best. A circle gives you the most area. So a little add on, shall we say. Okay, hope you enjoyed the lesson. Give the worksheet a go. I've, not too many questions on this. A few. There's a good challenge question on the end for you to play with, and I hope you can do well with it. All right. Take care, and we'll see you the next lesson.